put them close enough together so that you don't get any of these other funny spurs. But then you've increased the amount of mutual coupling, and then the rest of the 5 years is dealing with mutual coupling. Question?
Do you think there's room for improvement with AI and like future, I don't know, improvement on antennas?
Well, I suppose there are, although...
Or are we at the apex of...
I don't... If AI is simply something that looks at all of the literature that's ever been put out there and comes up with the best way to do it based on that literature, the answer would be no. Because these are all things that have been
already
created,
out there.
New ideas that have done this, and the simulation software. The simulation software, we've been doing stuff that you would call AI for the last 20, 30 years, actually, which is, I forget the term, but anyway, you let the computer go through iterations to find out. You give it a range of what you can let the parameters do, and you tell it just go. You know, and it might run overnight, and then it'll come up and leave you with the best one of all those parameters that you worked with. That's kind of like AI, but you're building it in the machine. Question?
Well, I've got a silly question. You mentioned rotating the iPhone and so forth together. So I remember Steve Jobs, when he was still alive, he said, if you want a better signal, hold your phone differently. It was almost sort of a quip. Is that interference? Is that, or?
No.
Okay.
It's finding
Basically the same kind of idea, right?
finding the source.
You have to both get the stronger part of the phone radiation pattern looking at the cell, and you have to get the polarization correct. Both of those things you can optimize by moving it around and just, you know.
You seem to be like moving his hand like those.
Sure.
That's what he was saying.
The hand doesn't really get in the way.
That's good.
No, I mean, it
Yeah.
it's not an issue. Any other questions?
Yeah,
To your brain.
I never understood how circular polarization worked, and you did it really finally made sense. But I've heard that there's, I don't know if this is right, clockwise and counterclockwise.
Yes, two different modes, totally independent.
But how do they do that with just two?
By the way they phase the two.
Oh, okay.
Normally, you have two dipoles, and one of them is 90 degrees in front of the other one, and that will create, let's say, for example, right-hand circularization.
Okay.
If you put it 90 degrees behind the other one, then it would be circular polarization.
And would
That
those,
would be left-hand.
would those act up your receiver, and you're receiving, you're sending out clockwise and you receive clockwise, you get a signal,
Right.
but.
If you don't, it's just like cross-polarized. If you're not working on right hand, then they won't connect.
Okay.
Okay? But one of them connecting to a linear polarization will connect in any orientation, but you lose half the power. Okay? If they're both circulating in the same way, then you don't lose any power.
Okay.
But with like one of these 18-inch dishes with one little circular horn up there, most of them probably have circular polarization in it coming from the satellite. That can actually be receiving two different channels, because one channel could be right circular and one channel could be left circular, and they'd both be independent, because when you have a circulator, you have, excuse me, there's an element in there that takes the circular polarization and turns it into linear. You put it behind the front, the horn of the antenna. You put it in there. And if it's right circular, it'll come through and it'll say end up linear at a 45-degree angle like this. If it's left circular, it'll come through and it'll end up 90 degrees perpendicular to that. So they're really two different modes, just like vertical polarization and horizontal modes.
Okay.
Question?
All insects have a pair of antennas. All insects have a pair of antennas. So human body, does it act as an antenna, a weak antenna? Have you heard anything? Because when I was a child, approaching an AM or FM radio, the reception, it would improve. Do you?
Well, I've only heard some cases where some insects have antennas. They're usually very, very high
For
frequency
sensors.
because they're very tiny, right? But I haven't really looked into that. I don't know
We don't.
the importance of that.
Like bees.
Now, there's one thing that I didn't get into here, and that, again, because I think it would have taken too long, is some indifference antennas. I don't think I know. Wait a minute. How do I think? Well, this doesn't move. Okay, I can't do it. If you had the little 6-element array that I had, if all 6 elements are all excited with the same power level and the same phase, they all work together as one antenna, and you're going to get one main beam out here, and then some little side lobes to it. But what if I take of the 3 on the left-hand side, have those at a plus power level, and this is at a minus for, in other words, a 180-degree phase shift? Well, what do you think you're going to get right on the axis? You're going to get 0, because these two are exactly the same, only one's a plus side and one's a minus. So you're going to get a null right on axis. And what you get is, rather than one big null, or one big beam, you get 2 beams like that with a real sharp null in between. And this type of antenna, using 2 antennas together out of phase with one another, creates a null on axis. And this is the type of thing that if I were going to go find a cougar or something around here that's got a net collar on it, and I want to go around and find one, I would use a 2-element antenna and set it up so that when you've got it spotted, the signal drops out. And that's very sharp and very precise. If you've got a broad pattern, it would just kind of get louder and louder and a little bit softer. You wouldn't know exactly where it is, but if you go with 2 antennas, you get a difference pattern. You get a sharp null, and it will get louder and louder, and then go zip to nothing, and then come back up again, and you would know very precisely your angle. But a difference pattern is part of the monopole system that I was going to talk about with the fighter arrays, where I showed they use 4 different sections. All right, if you took the top half as one antenna, and the bottom half as another antenna, and looked at them with this difference pattern between the two, you would get a pattern that had a lobe above the horizon and below where, well, we'll just say where you're looking at the horizon. Okay, you get a pattern above it, and you get a pattern below it. And so if you got a signal on one of those and not the other one, you would know that your target is above where you're looking or below where you're looking. So that's information, all right? A lot better than having one big beam out there that it's out there somewhere, okay? Then you look at the vertical line, and you take the right-hand side and left-hand side and do that also as a plus and minus receive. So you'll have 2 lobes with a null in the middle, and you'll see a receive that's coming from the right-hand side now, and before you saw it from the top side. You combine that 2 information, and now you know your target is in the right-hand quadrant, upper right-hand quadrant. So all you do is start turning your target to that upper right-hand quadrant, and you'll just bring that target right down to your axis. And if you're shooting a missile at them, your missile's going to hit them. And you get information on every pulse, and you're sending out radar pulses thousands of them in a second. So you're getting this information back very quickly. So you're using this monopulse, they call it monopulse, because in one pulse, you get directional information. Now, it only tells you what quadrant something's in, but that's a lot of information relative to no information. Because it tells you, just turn a little bit in that direction. The next pulse will tell you again. Next pulse will tell you again. And you just zero right in on it. Okay? That was developed during the Second World War, but it was never used in the Second World War because they didn't figure out how to get it into any application at that time. It was till after the war that they started using. Then all the fighters use those now. And missiles. How do you think they zero in? They don't just have a radar that shoots one beam out there. They got to figure out where the target is with respect to their beam, and they do it by monopulse. So, another question?
How would they do drones if they wanted to shoot a
Well,
drone?
the radars would be the same. It doesn't matter whether the drone is just a way of carrying something. The radars are,
You'd have, no.
or if you did it visually with a TV camera, well, that's different. There, you pick out the targets very easily, like we did with Maverick missiles back when they were talking about smart missiles where you fly them into a window, okay, after you launch the plane. Well, because the Maverick missile doesn't have a radar in the front of it, it has a TV camera. And you just lock that TV camera right on the window and the guy just steers it in like with a little steering thing. And drones have visual. When you see these things on TV and they show you in the news, they show you a picture of something like a building and they put a cross on it. That's the picture of getting back from a missile that's flying into that building. And then all of a sudden you see it hit it. Okay?
Speed goes right. Quick question, it doesn't open up a whole can. 5G, whatever.
What is
there
it?
any concern? Is there any concern that there's a problem, radiation problem, and so forth, for health and so forth?
I haven't heard of anything. You know, usually the higher generations of cell phones like that, they're doing more with, maybe a little bit with the phone itself, but a lot more with the towers. Okay? So the towers, like you see in my first picture, can you put the first picture up? Yeah. There was a picture of a cell phone tower on there.
I saw that.
Just the introduction.
Well, you just passed it. Oh, no, that one.
Okay, so you see here on the left-hand side, here's a typical cell tower, and it's broken into 3 different sections. And the cell tower radiates with these 3 elements off, and this 120 degrees. So now it's not worrying about 360 degrees, it's only worrying about 120 degrees. So it's 1/3 the number of signals getting involved, okay? And they've got arrays, they're using arrays here. That problem in a vertical arrays, which mean they would be very flat patterns. It'd be, the pattern of using the 3 arrays together would be a nice pattern that covers 120 degrees, okay? But it wouldn't be way up and it wouldn't be way down, it would be very flat. So it concentrates the power out around for the area, okay? And each one of these is probably made up of a whole stack of antennas in there, each one of them. And then you use that as one subarray for each subarrays, and then they go together and they cover the 120 degree section in this direction. And you can see Same thing for the other 220-degree sections around the whole tower.
Thank you.
Thank you.
Before we go, you might have some questions from online people, but before, no, okay, before we do that, I have a question which is related to the first question Shaheen was asking. Let's say I'm using the antenna as a receiver, and all of a sudden I'm bombarded by noise. What are the considerations that I have to have in the design to protect myself from that noise?
Well, noise is very broadband stuff. So like when you're driving down in a car and you're driving along listening to the AM
Noise
radio
is
and all
just
of a
the
sudden you start getting a bunch of static, it's usually coming from something like electrical transmission lines or something like that,
Interference.
power lines. I know there's one place on Valley Circle where I'm driving along there, there's always a lot of static. And then I get a half a block away and then it's not there anymore. So it's some noise that's coming in from the outside. There's not much you can do about that.
But in the optical domain, we used to work on agile systems that any noise coming has a spectrum. It's not completely flat
Right.
throughout the spectrum. As a spectrum. So if I can move my transmission or reception into a frequency band outside that, let's say, bell curve shape,
Sure.
then I should be okay. So all I have to do is to have the mechanism inside that moves the frequency to a range or a domain that is outside that
Well, yeah,
spectrum.
if you can get away from the noise, do it. Usually the noise is not a single frequency particularly, unless it's some device that's near you. And everything that we build has a radiation requirement on it to limit the radiation from it, okay? So like there's radiation limitations on microwave ovens, and even on refrigerators, anything else that's electrical, there's a radiation limit built into it. So obviously, if you can get away from it, but if the noise is there, noise is generally pretty wide.
Okay, if no other questions and there is no online question?
I think there was a comment about how clear the presentation was.
Well, I appreciate it.
Was there anybody on the Zoom?
Let's
Yeah.
Just
They're
thank
working
our
right now.
speaker one more time. And by the way, next month, Bob will be giving another talk. I think it will be August 27th, the third Thursday.
21st.
21st.
The
Thank
same
you.
room. The
That's
same
on the
room.
topic of
Same place.
Next room.
We do have
Come right
a-
in.
World War II atomic bomb.
Okay, we've got a question here.
Let me see if I can get this voice to show. You want to try to ask your question using voice or chat, Bill? Okay.
I think it's better on voice.
Okay, how are you?
It's in regard to a sort of an offhand comment that was made about Yagi antennas. And, as an amateur radio operator, I know a little bit about antennas. I've got a couple of Yagis. And I believe you said something about more than one reflector element on a Yagi antenna. No, I've never seen one that had more than one. I don't know if it was misspeaking or if there's not that much advantage to having extra reflector elements.
Well, the one picture I showed had a whole bunch of reflector antennas, but they're all in the same plane. They were not at different positions along the axis. They were in the same plane of the one, when you had one reflector antenna, the other ones were in that one picture. I think that same one was on the front page.
Okay, so, yeah, I did see corner reflectors there, but we're talking about elements in the same plane. The multiple directors, I understand, but.
Well, the reflectors in that picture on the right-hand side, they're all in the same plane, behind the active element.
I don't see them. I see a corner reflector, yes, but not in the same plane.
Well,
You talking about these? I'm not sure you can see the arrows.
Yeah, those,
Okay, so
It's,
those.
it's like a corner reflector, it's not really a corner reflector, because they're not at 90 degrees, okay?
but the,
They're just a combination of putting a bunch of elements up there to get more reflection. And they're not perfectly straight down, because then as you get further away from the element, it wouldn't be the same distance. They're trying to maintain the same distance to the active element. So they're slightly curved in towards the active element, both on the top and the bottom.
right, but you would not see multiple reflectors in line with all the directors that you've developed.
That's correct. You see one place where the reflectors are. Okay, so it's replacing a single rod reflector with multiple rods, but just trying to increase the effect of the reflector.
All right,
But it's not a corner reflector, because that's at 45 or 40, excuse me, 90 degrees.
90, 80, whatever it takes.
Well, okay. We always play with things like that. You end up. Okay, anything else?
Move it this way, move it that way.
That's all for me.
Very good. Thank you very much. Okay,